Hello students. So in this lecture I am going to discuss about nuclear instrumentation. So before proceeding further, what is nuclear instrumentation? Let me discuss what is radioactivity. So radioactivity, it is the spontaneous emission of radiation in the form of particles or high energy photons resulting from a nuclear reaction. That is, whenever a nuclear reaction occurs, then there is a spontaneous emission of radiation which might be in the form of particles or high energy photons. So this radioactivity is also known as radioactive decay, nuclear disintegration, or radioactive disintegration. While there are many forms, as I've told you, what happens in radioactivity when a nuclear reaction occurs, then there is a spontaneous emission of radiation. Now, there are many forms of electromagnetic radiation. As I have told you when I was teaching you in my previous lectures, I told you that there are many forms of electromagnetic radiation like X-rays, then visible light, ultraviolet region, etc. But they are not always produced by radioactivity. For example, a light bulb may emit radiations in the form of heat and light, yet it is not radioactive. So which substance will lead to radioactivity? Which substance will lead to this process of radioactivity? So a substance that contains unstable atomic nuclei. Again I am repeating, a substance that contains unstable atomic nuclei is considered to be radioactive, and that substance will lead to the process of radioactivity. So radioactive materials emit nuclear radiations which mainly consist of alpha, beta or gamma rays. These alpha, beta and gamma are collectively called ionizing radiations. They are called so because they carry enough energy. These alpha, beta and gamma are called ionizing radiations. Why? Because they carry enough energy to ionize or remove electron from an atom. That is, what is ionization? As we know, ionization is the addition or removal of an electron to create an ion. So these alpha, beta and gamma, they carry enough energy to ionize or remove electrons from an atom. Now, when this radiation encounters, what will happen when this alpha, beta, gamma radiations encounter living cells? What will happen? It can cause heating, it can break chemical bonds or ionize molecules. So the most serious biological damage results when these radioactive emissions fragment or ionize molecules. For example, alpha and beta particles emitted from nuclear decay reactions possess much higher energies than ordinary chemical bond energies, and when these alpha beta particles strike the atoms, strike the matter and penetrate the matter, they produce ions and molecular fragments that are extremely reactive. The damage these radiation does to biomolecules in living organisms can cause serious malfunctions in normal cell processes, thereby taxing the organism's repair mechanisms and possibly causing illness or even death. So the ability of radiation to damage molecules is analyzed in terms of its ionizing power. When a radiation particle interacts with atoms, the interaction can cause the atom to lose electrons and thus become ionized. So much of the threat from radiation is involved with the ease or difficulty of protecting oneself from the particles or the gamma ray. So how thick of a wall do we need to hide behind to be safe from these alpha, beta particles or gamma rays? So the ability of each type of radiation, by radiation here I am trying to say about alpha particles, beta particles or gamma rays. So the ability of each type of radiation to pass through matter is expressed in terms of its penetration power. The more material the radiation can pass through, the greater is the penetration power and the more dangerous those radiations are. So as I have told you, the types of radioactive rays are alpha rays, beta rays and gamma rays. Let's study each of these rays in detail. So alpha particles. Alpha particle is a helium nucleus consisting of 2 protons and 2 neutrons. It has a mass of 6.64 into 10 to the power minus 27 kg, and it carries a positive charge of 3.2 into 10 to the power minus 19 coulomb. So this, because of the heavy mass, the alpha particle is the heaviest and the slowest. So because of the large mass of the alpha particle, it has the highest ionizing power and the greatest ability to damage tissue. That same large size of alpha particles, however, makes them less able to penetrate matter. They collide with molecules very quickly when striking matter, add 2 electrons and become a harmless helium atom. Alpha particles have the least penetration power and can be stopped by a thick sheet of paper or even a layer of clothes. So they are also stopped by the outer layer of dead skin on human beings. This may seem to remove the threat from alpha particles, but only from external sources. If the alpha particle is present externally, so the threat from it can be removed. But in a situation like a nuclear explosion or some sort of nuclear accident, where radioactive emitters are spread around in the environment, the emitters can be inhaled or taken in with the food or water, and once the alpha emitter or alpha particle is inside us, we have no protection at all. Therefore, due to short range of absorption and inability to penetrate the outer layers of skin, alpha particles are not in general dangerous to life unless those alpha particles is indigested or inhaled. Next is beta particle. Beta particles are basically beta particle is an electron with the mass of 9 into 10 to the power minus 31 kg and a charge of 1.6 into 10 to the power minus 19 coulomb. They are much smaller than alpha particles and therefore they have much less ionizing power. That is less ability to damage tissue. More ionizing power means more ability to damage tissue. Less ionizing power means less ability to damage tissue. So since they are smaller than alpha particles, they have much less ionizing power compared to the alpha particles. But their small size gives them much greater penetration power. So most resources say that beta particles can be stopped by 1/4 inch thick sheet of aluminium. So once again, however, the greatest danger occurs when the beta emitting source gets inside us. So what I'm trying to say is that although beta particles can be stopped by this sheet of aluminium, but once it get inside us, we have no protection at all. It can cause danger to us. It is hazardous to us. The next is gamma rays. So gamma rays are not particles like alpha particles and beta particles. They are particles. Gamma rays are not particles but a high energy form of electromagnetic radiation like X-rays, etc. So except gamma rays are more powerful. So gamma rays are energy that has no mass or charge. They have tremendous penetration power and require several inches of dense material like lead to shield them. So gamma rays may pass all the way through a human body without striking anything, and they are considered to have the least ionizing power and the greatest penetration power. So therefore, radioactive materials that emit alpha particles and beta particles are most harmful when swallowed, inhaled, absorbed or injected. Although beta particles can partially penetrate the skin, causing beta burns, whereas alpha particles cannot even penetrate the intact skin. But however, if alpha particles or beta particles, that is those radioactive materials that emit alpha and beta particles, if they are however swallowed or inhaled or absorbed, they will be very harmful to the human body because they have the very high ionizing power. Although gamma rays do not have that much high ionization power, but since it can penetrate inside the human body, they are most harmful external hazard. They are most harmful external hazard. Alpha particles and beta particles, when they are present externally, they cannot cause that much damage to the human body. But whereas gamma rays, since they can penetrate inside the human body, although their ionizing power is less as compared to alpha and beta particles, but since they can penetrate through the human body, they are the most harmful external hazard. So this was all about alpha particles, beta particles and gamma rays, means those radiations that are emitted during a nuclear research or during a nuclear work. So these are the radiations. Now in my next lecture, I'll be discussing about the instrumentation or the methods for measuring the amount of radioactivity and for tracking of this radiated alpha particles, beta particles and gamma radiations. So I'm ending this class here. Thank you.